Excellent. I've now chased away all of my colleagues and can properly begin. So hi, everybody. My name's still Dan Illson, and we're going to do another talk on Kubernetes application logging specific to our VMware Kubernetes engine offering. All right, so we're going to look at that specifically on top of that platform. So apologies to some of you who may have seen this in the previous talk, but we'll cover it briefly yet again. So here at VMware, we now have our whole umbrella of VMware Cloud Services. The services we're offering that are SaaS delivered and attached to native public clouds as well as on-premises environments. Many of the services in this bundle are more operational in nature, and we'll talk a little bit about one of those operational domains today, but they also focus on runtimes in the public cloud. So for example, there's VMware Cloud on AWS that many of you will be familiar with, but also VMware Kubernetes Engine for folks that want to consume Kubernetes as a managed service without having to go through some of the steps and machinations of setting it up and running it directly themselves on premises. Okay, so as we talk about Kubernetes offerings here at VMware, we do have kind of a couple ends of the spectrum. PKS, which many of you will be familiar with, is the more self-managed direction to go and a little more self-determined in terms of getting set up, getting the optionality done. VKE, or VMware Kubernetes Engine, is the managed service end of the spectrum. It is targeted at people who want to consume Kubernetes clusters as quickly as possible, get up, start deploying, and keep moving. Okay? That is who VKE is targeted at. We've launched the service into public beta, and we've been out in public beta for a little while now. Okay. VKE is fundamentally made up of smart clusters, which are our Kubernetes clusters with some accompanying scaling and operational logic built around them. Fundamentally, within the VKE service, we have two types of clusters. We have a development cluster that isn't strictly isolated and has a smaller resource footprint, only lives in one availability zone. And then we have a production or enterprise cluster, which is built for 3 availability zone redundancy or high availability. It sprays worker nodes across all of those availability zones, and it's strictly isolated within its own VPC. This means it can have a unique networking space, which we can use for features such as VPC peering out to other services and other environments, and discussed that a little bit in my last talk. This talk, we're going to take a little more of an application-centric view and look at how we get logs out of VKE itself from a cluster perspective, and also the Kubernetes pods that make up an application. Okay. From here, this takes and blows up the block diagram a little bit of a production cluster inside of VKE. Across the top, we have our container pods and namespaces that make up a Kubernetes cluster and a deployment at that level. Down below, we're showing master and worker nodes and how, from a production cluster standpoint, we deploy them across multiple availability zones, but isolated within a given VPC. That's the model for our production clusters, right? When a VKE cluster comes up, it has a few things in it. In the case of a production cluster, it is set up across 3 availability zones for resiliency. Comes up with an Nginx ingress controller to use to access services that you deploy inside. And it comes up with a VKE-system namespace that has our service-side tooling already installed in it so that the cluster is ready for you to start deploying in from the time it comes up and shows ready. Okay. When we talk about logging inside of Kubernetes, there's a couple ways to look at it, because there's a couple ways to look at attaching operational services to Kubernetes environments in general, right? Fundamentally, it kind of drops into 2 approaches, right? You can go the Daemonset approach route, which involves taking a container deployment and placing 1 pod on each node in the Kubernetes cluster so that there's a ubiquitous access point available for that service no matter which node you happen to live on. And you approach it from that direction. Everybody spits their information locally towards that Daemonset collector or Daemonset process, and then it handles it from there. Or you can go down more of the sidecar or proxy route, where you actually take a container and inject it inside the Kubernetes pod itself alongside your service, and you use it as a way of saying basically everything that goes on inside this pod, that container, that sidecar container is now aware of. It can access it, it can see it, and it can act on it as appropriate. For example, some of the previous presentations on this stage talking about things like Istio, right, where we look at Envoy. Envoy is more of a sidecar model that acts as a proxy. Some other things, like if we talk about Wavefront, for example, for metrics collection, will operate much more on the sidecar route. For something like logging, where we're going to want to grab information from both the cluster and node level as well as the application pods themselves, a Daemonset makes sense because it allows us a ubiquitous way of accessing this for any of the resources on that node, and it doesn't require us to potentially deploy multiple sidecars in multiple pods that may all happen to live on the same node. So it's a little more resource efficient, so to speak, I guess, from that perspective. Anyway, these two approaches work that way. As far as logging, we're going to talk about this from a Daemonset perspective. That doesn't preclude anyone from doing it via a sidecar method, but if you do it via a sidecar method, you have to figure out how to get the cluster and node logs separately, because all you'll get really is the application pod logs going down that sidecar methodology. Right? So to do this in this environment, we're using a Fluent bit Daemonset implementation, right? So anybody familiar with Fluent D or Fluent bit, those projects? So Fluent D's been around for a little while as a log forwarder, an aggregator from the open source space. Fluent bit is a little more pared down and a little more streamlined for use in Kubernetes environments. Fundamentals are more or less the same. Ideally, in this case, what it's doing is it's taking the logs that are sent to it and it's acting as a parser and forwarder for those logs. In our case, we're taking those logs and we're forwarding them off to an Elasticsearch instance to use that as our log stash, and then we'll visualize them in a Kibana instance as well, where it gives us a chance to look at it. Very elk stack type approach, way of doing this. So in this case, our Daemonset's actually grabbing cluster logs, individual node logs, and then our pod logs as well. Okay. On the bottom there, if you want to go check out some of the Kubernetes resources from FluentBit, their GitHub's right there. They've got some nice Daemonset YAMLs and other things up to either use yourself or use as a base for what you want to do yourself in your own environment. Okay. So this image will help us look at our Daemonset a little bit, or our implementation for the demonstration. Again, we are based off of that FluentBit Daemonset that we've put on all of our nodes across the cluster. Those are all forwarding out to an Elasticsearch instance in AWS. From there, going to a Kibana instance for visualization. Okay. At the bottom here, our demonstration app that we're using today is fundamentally MySQL database backend, and a Django web server, and a Flask API server. So very Python and MySQL heavy in terms of this app. And then before we look at the live app running, we'll actually look at a little bit of the config. So this is from the FluentBit Daemonset config that we've used, right? So there's a couple different pieces of it. One is defining just the FluentBit service that goes in fluentbit.conf. So what are we looking at? We're grabbing info level logs. What are we listening on? And then we're including both a Kubernetes input file to define how we take input from Kubernetes, a filter, and then an output file for all those Kubernetes logs, right? So our input file is presented right next to it to the right. Basically, we're grabbing kube.star, so everything that's coming out of Kubernetes from a logging perspective, and running it through the Docker parser that they have already defined there. So basically, grabbing up everything, we want it all to come in, parse it based on Docker parsing rules. And then we've got a couple other pieces, right? So we do have that Kubernetes filter, where we're filtering it based on the default namespace and cluster local services, right? So you can look at the kube URL there that we're matching on. Again, we're matching all the logs coming out of Kubernetes and running them through the K8's logging parser. And then we have an output file where we're outputting to Elasticsearch. So this is where it's defining the Elasticsearch host and port. Obviously, we're using environment variables for those, and throwing them into a log stash format coming out. Now in that file, there's a few different parsers. I've just reproduced the syslog one here so that we don't have a whole mess list of about 10 of them that are impossible to read. But if you look, these parsers all follow generally the same format. We define a type, and then this is a regex expression matching one. So it's matching on a regex format that it recognizes to be syslog and applying a timestamp to them as well as to when it grabbed and forwarded them. Again, most of this config you'll find out there. Fluent Bit provides a lot of this out of the box, but it's good to know what's there, what's actually acting, and what's being used to do some of these things. So from here, we'll jump out into our demo environment and our demo application real quick. So we can close my previous demonstration tabs and find my new one. So, for example, this we've deployed in one of our clusters here inside of VKE, so I'm going to navigate to that now. Right. Now, if we look in here, on this particular cluster, we've defined a logging namespace, right? So that logging namespace is where we've put our Fluent Bit Daemonset collectors to aggregate all of our logs. We did that so that they're in one consistent place. And because of that, and the way Kubernetes handles services, that namespace is going to come before the service name when I reference it by the internal cluster DNS, right? By putting it in a logging namespace that allows me a little more consistency across multiple clusters, I can just now name my service the same thing and not have to worry about colliding with something else that someone's deployed inside that cluster because I've put it off to its own namespace first and foremost, right? So we've got that here. Now, from here, as before, we can log into our authenticated Kubernetes UI. And if we want to, from here, we can come out and filter based on that logging namespace. Right? What we'll see is there's only one thing really going on in this logging namespace. It's a Fluent Bit Daemonset. And because we have one worker node in this cluster right now, it's deployed one Fluent Bit pod. Right? And we'll see the information about it here. Remember those two environment variables from our output file before? Right? So if I log up, if I scale up my screen a little bit and move to it, there are those two environment variables coming back that we saw before, except where they were kind of wildcarded out before and just sitting as variable names. Here we can see that based on our deployment YAML that we use, they've been filled in, and they're now pointing to our specific Elasticsearch instance and port, right? Which is good, because in a minute, we're going to go to that particular Elasticsearch instance and port. Although I may have to log into that by HTTPS. It's not going there right now. OK. Come back to here right now. So there we are logged in there. Now, I can also look at this from our command line package, although it will require me to switch my kubectl context over to that cluster. Luckily, the VKE CLI has a nice command for that to help me move over to that cluster. So I want to go to prod 5. And as soon as I do that, I can see, I can look at any of my kube control commands just like I would from any other Kubernetes cluster. Except now that I know that we care about the logging namespace specifically, I'm going to give it the -n namespace flag to make sure. Right? And there's my same pod running in there. Okay. So if I want to get into that directly, I need to bring my bookmarks bar back. So I can go to our Kibana instance. Now, our Kibana instance here is looking at that same Elasticsearch store that we were specifying previously. And this is going to allow us to help visualize all of the logs that we're looking at and see what we're actually getting out of this cluster. Right? Now, the nice part here in Kibana is that it has parsed a lot of these logs for us already and given me some values that I can look at. Now, For me, what this means is I can come in here and I can specify, say, a particular Kubernetes host. And if you look, there's my worker node that's reporting out, right? So that worker node, based on the name of it, I'm seeing all of my logs come from there, or most of my logs come out of there, right? And if I want to, even though it's very small, I can grab the plus there and have it filter my logs based on just logs that have come out of that particular worker node, that particular host, right? So I'm seeing these all show up here. From here, I can even further refine it, right? So for example, I'm going to take the name of one of the functions or pods that I'm looking at. If I look at my, nope, I don't want namespace, I want my pod names. Here I can see I have a lot of logs coming specifically out of one of the canal nodes. Now, the canal nodes are reporting in, this is part of VKE's system, right? This is part of the underlying guts of VKE that's running the cluster. So I'm actually getting these nodes, I'm getting logs from these nodes because they're sitting in that node port, or because they're sitting in that daemon on the node, even though I haven't exactly specified to go grab from there, which is always interesting to look at. Oop. Kill some of my filters here. I hit one too many, and now I can't get rid of them all. So let's say I come out of here. Now, I can go in here and grab from a variety of different filters. So let's see. I can grab based on the Kubernetes pod name here, and there's one of my API servers that run this app. So let's try to filter based on this guy. And this will allow me to grab up and look at my logs specifically coming out of that one API server, right? Now what I'm going to see coming from here is a lot of get commands, because again, the API server is just allowing me to do a read of my database. It's just a Flask server with a couple paths that's just reading from the database upon request. So I'm going to get, I should get mainly successful get HTTP requests. If I get something else, something non-optimal is happening. And I can look at volume over time, right? So up at the top, they're visualizing volume over time. It should be pretty steady, because again, we're basically running a traffic generator script against it to populate some of this. But you know, if it becomes not ideal or deviates substantially, I'll be able to see that visualized here. And then this application itself, we can verify that this thing is up and live and probably push a couple extra logs with new timestamps in. So what we'll do is I'll do a VKE cluster show based on my cluster. I'm doing that just to grab the ingress URL for the cluster. And then if I come back here, this leads us to the web front end for our wonderful app, which I know at least some people in the front row love to death. We can use it as a web form just to trigger the flow here. We will make up a human being to protect the guilty. So that's pushing a record into our database. We'll see that log come through. And we can also hit the API server end of this. Now, if I hit just the general front page, my API server yells at me and tells me I haven't followed the right path. But I can navigate through here. And this is doing this is basically doing a read. The Flask server is doing a pull from our actual database itself. So if I refresh that a few times and then swap back over to our Kibana instance, don't know that we'll see it visualize right away necessarily, but we should be able to see from an API server perspective, you know, a recent bucket of requests, and that's basically me just hitting all of those through on a refresh perspective. The nice part about doing this way with Elasticsearch and Kibana is that it has done a lot of this filtering for us and made these filters easily accessible, so I have a little more visualization. But from using this methodology to pull logs out, you could forward them to any sort of log stash, whether it was Elasticsearch or something else, and from there on to any log aggregator or filterer you wanted to use, whether that was something like Log Intelligence from VMware or what have you, whatever particular log aggregator you want to use and is available to you in your environment. So that'll cover the basic approach, kind of what we did, how we set it up. My colleague, Mr. Shetty in the front here, has published a blog article on this that's up on the cloud.vmware.com community blog that has a lot of the specific implementation details and code snippets if you want to go look at that in depth. A lot of that stuff is out there, and we have it as well. I'm happy to answer questions about it. So at that point, I'll stop and ease up unless anyone has any questions that they want to ask specifically about what was here. No? Excellent. Well, in that case, I will cede the floor and let my colleagues come up and do the next piece on CI/CD. So thanks very much, everybody. Thanks for coming by. Appreciate it.